Stellar Odyssey, humanity's next 1,000 years. Setting the stage. Imagine waking up one day, not on Earth, but under the twin suns of an alien world. What would breakfast look like? Would coffee even exist? From the first moon landing to Mars rovers and SpaceX rockets, humanity's space journey has just begun. But what's next? Where will humans call home in the year 3025? Will we stroll under alien skies or sip synthetic lattes on distant worlds? Let's find out. The cosmic neighborhood. Planets that could be colonized. Imagine looking up at a crimson sky, standing on dusty red soil, with Earth appearing as just a bright dot among countless stars. Welcome to Mars, humanity's first serious contender for colonization. It's the obvious candidate. Close enough to reach within a few months using current technology, with days just a bit longer than Earth's and polar ice caps full of water. Sounds like a cosmic fixer-upper, right? But here's the catch. Mars has low gravity, about 38% of Earth's, a paper-thin atmosphere mostly made of carbon dioxide, and radiation levels that would make your average sunburn feel like a mild summer breeze. Terraforming Mars, turning it into an Earth-like paradise, would be like trying to turn a rusty, abandoned warehouse into a luxury resort, without a toolbox. Still, if there's one thing humans excel at, it's stubborn determination. But Mars isn't the only celestial address on our cosmic real estate tour. Next stop, Europa and Enceladus, two icy moons orbiting Jupiter and Saturn, respectively. Beneath their frozen crusts lie vast subsurface oceans. Think of them as cosmic snow globes with hidden salty seas. If life exists there, would it be more like alien shrimp or space squids? The idea of discovering extraterrestrial sushi may sound amusing, but it raises profound questions about life beyond Earth. Colonizing these moons would be less about beachfront property and more about under-ice research stations, kind of like Antarctica, but with more spacesuits and less Wi-Fi. Now let's venture to Titan, Saturn's largest moon. Picture this: rivers and lakes, but not of water, of liquid methane and ethane. It rains hydrocarbons. Great for future chemists, maybe not so much for beach lovers. With its thick, nitrogen-rich atmosphere, Titan offers some protection from radiation. But you'd still need to wear a pressure suit unless your dream vacation includes a toxic smog ambiance. Oddly enough, Titan might be one of the most Earth-like places in the solar system, just colder. Like minus 180 degrees Celsius colder. Bring a jacket. And finally, beyond our solar neighborhood, we find the tantalizing allure of exoplanets, worlds orbiting distant stars. Super-Earths like Kepler 452b sit in the so-called Goldilocks zone. Not too hot, not too cold, just right for liquid water. These planets could be rocky, with thick atmospheres and gravity slightly stronger than Earth's. The catch? They're light years away. Even traveling at the speed of Voyager 1, it would take tens of thousands of years to get there. But who knows? In the next 1,000 years, we might crack the code for faster-than-light travel, or at least build generational ships where entire communities live, grow old, and pass on the dream of reaching distant worlds. From the dusty plains of Mars to the icy oceans of Europa, the methane lakes of Titan and the distant glow of alien suns, our cosmic neighborhood is filled with possibilities. The question isn't just where we can go, but how we'll get there, and who we'll become along the way. Life in space. How will humans adapt? Imagine waking up in a space colony, looking out the window, and instead of blue skies, you see a dusty Martian horizon or the swirling clouds of Jupiter. The question isn't just, can we live in space? But how will we adapt to these alien environments? First, let's tackle the basics. Surviving without Earth's cozy atmosphere. Gravity is a big deal, literally. On Mars, it's only about 38% of Earth's. Sounds fun, right? Superhero jumps and effortless flips. But there's a catch. Prolonged exposure to low gravity can weaken bones and muscles. Think osteoporosis on fast forward. To combat this, future space habitats might incorporate artificial gravity using spinning habitats to simulate Earth's pull. Picture living inside a giant rotating donut in space. Yes, like an intergalactic Krispy Kreme, but with more exercise bikes. Then there's radiation. Without Earth's magnetic field as a cosmic umbrella, space travelers are exposed to higher doses of radiation. Picture getting a full-body X-ray every day, not ideal. Radiation shielding will be crucial, using materials like water, polyethylene, or even Martian regolith, aka space dirt, to build protective layers. Imagine underground Martian bunkers doubling as both cozy homes and radiation fortresses. Now let's talk about the Martian diet. Growing food on alien worlds isn't as simple as planting a tomato in Martian soil. For starters, Martian soil contains perchlorates, chemicals that are toxic to humans. Yum, right? Future space farms will likely rely on hydroponics or aeroponics, growing plants in nutrient-rich water or mist without soil. Think of it as futuristic zero-gravity gardening. Space salad, anyone? But adapting might go beyond technology. Enter genetic modifications. Would we need to tweak our DNA to survive on alien worlds? Maybe. Scientists speculate that future spacefarers could have enhanced bone density, radiation-resistant cells, or even altered metabolisms to thrive in low-oxygen environments. Introducing Homo spaciens, the next evolutionary step. No, we won't grow green skin or antennae. Probably, but subtle genetic shifts could give us the edge needed to call space home. Funny thought, will Martian kids find Earth's gravity too heavy? Imagine visiting Grandma on Earth and complaining about how exhausting walking is. Ugh, Mom, why is Earth so heavy? It could happen. Over generations, human physiology might shift so much that Earth feels like the gym all the time. Adapting to life in space will be the ultimate human challenge. But if history has taught us anything, it's that we're remarkably good at adapting. After all, we went from caves to skyscrapers, from stone tools to smartphones. Who's to say the next stop isn't the stars? Predicting the future. Scientific forecasts for the next 1,000 years. Close your eyes, unless you're driving, and imagine flipping through the pages of humanity's future. What do you see? Hovering cities on Mars? Alien handshakes? Spaceships cruising faster than light? Let's take a bold leap across time, from the near future to the farthest cosmic horizons. Near future, 50 to 100 years. By the time your grandkids are complaining about their Martian math homework, we could have permanent moon bases. Picture sleek, domed habitats nestled in lunar craters, powered by solar panels stretching like metallic sunflowers. Mars colonies? Check. SpaceX, NASA, and maybe even Lunar B&B competing for interplanetary travelers. Asteroid mining will be big business. Imagine digging into a giant rock worth more than all the gold on Earth. Plus, space tourism will be the new luxury getaway. Forget beaches. How about a weekend orbiting Earth? Medium term, 100 to 500 years. Here's where it gets wild. Terraforming attempts on Mars. Think of it as cosmic landscaping, trying to warm up the planet, thicken its atmosphere, and maybe even create rivers and forests. Will we succeed? Maybe partially. Meanwhile, robotic interstellar probes will venture beyond our solar system, like high-tech message bottles tossed into the cosmic ocean. And yes, the big question, first contact. Will we meet intelligent alien life? Will it be a friendly, hello, neighbor, or a we come in peace, or do we situation? Either way, humanity's sense of we will expand beyond Earth. Far future, 500 to 1,000 years. Now buckle up. We're talking Dyson spheres, massive structures built around stars to capture their energy. Imagine turning an entire star into a cosmic power plant. Faster than light travel? It's the holy grail of sci-fi, but who knows? Wormholes, warp drives, concepts once thought impossible may become reality. By this time, humans won't just be an Earth species. We'll be a multi-planetary, perhaps even interstellar civilization. Imagine cultures shaped by alien skies, art inspired by rings of gas giants, and children who think Earth is just that old planet where Grandma was born. Throughout it all, one thing will stay the same: our insatiable curiosity. Because the final frontier isn't just space, it's the boundless future ahead. How space colonization will change life on Earth. Imagine this. You're brushing your teeth with water purified by technology originally designed for astronauts. Or maybe you're checking your GPS, which relies on satellites born from humanity's first tentative steps into space. These are examples from today. Technological advancements already part of our daily lives thanks to early space exploration. But space colonization isn't just about leaving Earth. It's about how reaching for the stars will ripple back and change life right here, both now and in the future. Technological boomerangs. Let's start with the unexpected souvenirs from our space adventures. Right now, innovations like advanced water purification systems, scratch-resistant lenses in your sunglasses, and even memory foam for your comfy mattress stem from space technology. But as we push further into the cosmos, future colonies on Mars and beyond will drive even more breakthroughs. Ultra-efficient energy systems designed for harsh extraterrestrial environments, medical advancements tailored for zero-gravity conditions, and new materials stronger and lighter than anything we currently have. What began as tech for survival in space often circles back to make life better here on Earth. Cultural shifts. Now imagine life a few centuries from now. Picture a world where school kids learn Martian history alongside Earth's ancient civilizations. New languages could evolve, blending Earth dialects with the slang of space settlers. Time zones? Forget GMT. How about SMT, Standard Mars Time? With days lasting 24 hours and 39 minutes, scheduling interplanetary Zoom calls might require some creative calendar hacks. Holidays like Founders' Day of the first Mars landing could become as celebrated as Earth's own historical milestones. These cultural shifts aren't science fiction. They're the natural evolution of humanity as we adapt to life beyond our home planet. Philosophical reflections. But here's the cosmic question. If we live on multiple planets, will Earth still feel like home? Imagine being born on Titan, growing up under its hazy orange sky, and visiting Earth for the first time. Would it feel like a foreign land or an ancestral cradle? As humanity spreads across the stars, our identity might shift from Earthlings to humans of the solar system, sparking new philosophies about belonging, heritage, and what it truly means to call a place home. In the end, colonizing space isn't just a technical journey. It's a transformation of who we are. Every star we reach will reflect back, reshaping life on Earth in ways we've only begun to imagine. The human side of the universe. Imagine the day when humanity welcomes its first Martian-born child. a tiny heartbeat echoing not on Earth, but under the thin atmosphere of a distant red world. That child wouldn't just be a person. They'd be a symbol, a living milestone in our species' story. The first true Martian. Imagine the first breath they take, the first steps on gravity that's just 38% of Earth's. Will they see Earth as the distant old country, or as a mythical cradle of humanity? With new lives come new cultures. As Martian colonies grow, people won't just import Earth's traditions, they'll create their own. Imagine Founders' Day, celebrated on the anniversary of the first human landing, or solstice under two suns for colonies near Mars's poles. Languages will evolve, too. A mix of Earth's languages blended with Martian slang, shaped by new environments and experiences. Kids might speak Earth Standard in school, but swap Martian Creole with friends. And with survival driving innovation, Martian life will push science to its limits. The harsh conditions will demand breakthroughs in sustainable energy, like ultra-efficient solar panels designed for Mars' weaker sunlight. Medical technology will advance to treat conditions caused by low gravity. Think bone density regeneration and muscle atrophy reversal therapies. Even environmental science will leap forward, as terraforming experiments teach us how to manage ecosystems on both Mars and Earth. Ironically, the challenges of living off-world might save our home planet. Techniques to grow food in barren Martian soil could revolutionize agriculture in Earth's deserts. Closed-loop water recycling systems perfected on Mars could address droughts back on Earth. In trying to thrive on Mars, we may discover the keys to healing Earth itself. The birth of the first Martian child won't just mark the start of life on another planet. It'll be the beginning of a new chapter for humanity. A chapter where Earth is no longer the center of our story, but the first page in an ever-expanding cosmic tale. Are we destined stars? As we stand on the brink of a new era, staring into the vastness of the cosmos, one question lingers. Are we destined for the stars? Humanity has always been restless, driven by an insatiable curiosity. It's what led us out of caves, across oceans, into the skies, and eventually beyond the fragile blue shell of our atmosphere. The same spark that lit the fires of ancient explorers now propels rockets toward distant worlds. But space isn't just the final frontier. It's the next chapter in the story of us. Each step we take beyond Earth isn't just about survival or discovery. It's about redefining what it means to be human. Imagine standing on a distant exoplanet, looking up at a sky filled with unfamiliar stars, feeling both small and infinite at the same time. That sense of wonder, of connection to something larger, is woven into our DNA. As we build colonies on Mars, sail among the moons of Jupiter, or venture toward distant exoplanets, we're not just spreading our species, we're spreading our stories, our cultures, our dreams. We'll create new myths under alien skies, write poetry inspired by the glow of Saturn's rings, and paint art that captures the swirling storms of Jupiter. Yet, perhaps the greatest realization will be this. No matter how far we travel, the most profound journey isn't measured in light years. It's the journey of understanding ourselves, of growing beyond the boundaries of our origin. Maybe, just maybe, the real destination isn't a planet. It's the journey itself. The story of us becoming more than Earthlings, of embracing the universe not as visitors, but as part of its vast, eternal tapestry. So, are we destined for the stars? Or have we always belonged to them, waiting for the courage to find our way back? Dear friends, thank you for listening to our audiobook. If you enjoyed it, don't forget to give it a like and subscribe. Want to explore more about the future and scientific predictions? Hit that subscribe button and click the notification bell so you won't miss our upcoming thrilling audiobooks and fascinating scientific forecasts. We'd love to hear your thoughts. Leave a review and share your ideas about our shared future.